ನನ್ನ ತಮ್ಮ ಹೇಳ್ದ ಐಪ್ಯಾಡ್ ಇರುತ್ತೆ ಕಣ ಮ್ಯಾಕ್ ಅಂತಿದ್ದೀನಿ.
So we'll be looking into the programming with OpenGL. So this chapter is the second part of your module 1. So how do we write the graphics program and what are the things which are required? So we need an API, we need a header file. So as we all know, which is the header file which we'll be looking into, it is a graphics library, gl.h. Hash include gl/glet.h, so that will be the header files. So program structure looks in this way. The first is we include the header files. Then most of the OpenGL have the similar structure as that of C programming. One is we have the main method followed by init method, then init shader, and we have some callback functions. So main function is where the execution of a program actually starts from. So specifies the callback functions, meaning, so if I have any other functions where I have to go, so that will be specified here, meaning the calling function opens one or more window with the required properties, enters the event loop. So all these three things will be taken care by the main. So we have the init method which sets the state variables. So there are two. One is for the viewing and the other one is for the attributes. Viewing is for in which uh, transformation you are using, meaning are you looking from in front or on top or on the side. So attributes is nothing but the color, size, uh, those will be the attributes. So int shader is used for dealing with the shading part. So callback function is display function. Usually display function will not be in the main, it will be outside the main. Main duty is from the main, I have to move to display function, and I have some input and window functions also, which we can see. So main function, as I told you, it is used for glut functions. I have init for the colors. Initially, what happens is I have the buffer. I have a buffer, right? And in that buffer, uh, the question is previously somebody would have drawn in that buffer. So the buffer is not empty. That buffer will be having some data. So how do we deal with that data? So we have to clear that particular buffer. So for that we actually use the init, right? So which allows us for the flexible colors. So next is so that's about the init. So next comes the init shader, which I told you speaks about the shading part. So the key issue is that we must form a data array to send the GPU and then render it. So whatever the data which we are using, has to be sent to the CPU, right? So that particular issue from the CPU information will go to the GPU. So GPU starts rendering it, and then it starts rendering it, meaning it will go to the monitor, right? So it goes to the monitor, and it can be a screen, it can be some display. So many things, many cases. So main program uh, of a graphics program looks in this way. So it has something called as preprocessor directives. Preprocessor directives. Next, it has the main method where execution starts from here. Execution starts from here. These two things, as of now, we have to write. Because if in case you are accepting any input to the program, that argument count, how many inputs you are taking, that will be present over here, and what are the outputs which will be present will be in the terms of pointer, which will be pointing to this vector. So these 2-3 lines are compulsory, you have to write regardless of whatever it is, right? So preprocessor directives, any graphics program will have a preprocessor, it will have a main, and it will always, you always have to write these statements from here to here. Okay, one is initialize the argument count and argument vector. Next comes the display mode, meaning here you have two things. One information is about the buffer and one information is about colors. So if in case the glut single refers to it is only one buffer. So if you have double, meaning it has two buffers. When you have single buffer, there is no change in colors. When you have single buffer, there is no change in colors. When you have double buffer, there is change in colors. So glut RGB refers to you are using color. Indirectly, you are telling the program that I'm using colors for my evaluation. So this
Sorry,
buffer is nothing but it's a place,
uh,
right? It's a place where it has some information, right? So this information, if I have only one buffer, so meaning it is static. There is no change, right? If I have two buffer, meaning I have another buffer. By the time you fill this becomes empty, and when it is full, gets filling, and this will be made as empty. Why? Because we don't need to waste our time. If you are wasting the time, the image will get something called as glitch. You cannot see properly. So in order to avoid the glitch, you use two buffering. So if you have one buffer, problem is you have the glitch. So next is, init window size. So window size is nothing but previously we saw one program here, right? So
square.
Yes. So this is the window size. So with respect to the x-axis and with respect to the y-axis, so this is 500 pixel from here to here, and from here to here it is again 500 pixel. Okay, so that's about the window size. So I think this is done. So next comes the window position. Window position 0, 0 refers to whether that 500 window should come over here, it should come over here, or it should come over here, or it should come over here, or wherever you want that 500 pixel, by 500 pixel, wherever you want, you can locate it. Most of the time, it will be taken it as 0, 0, meaning it will be on the top. It will be on the top. Next, create window. You have created that particular window, right? On the top, you need to give some name. That name is over here, simple. And this particular line of code actually gives that. Next, we have this is where the logic goes actually. So display callback is the logic of your graphics, right? So next comes the glue init, which just initializes few things. And the init method is used to initialize the shaders. Only if you just need to call, you don't need to do anything else. Then whatever you're displaying, if you want it to be in a loop, it unless until you terminate, it should be there, right? So for that we use the glut main loop so that it will be in the loop and the output will be there. If you are not using the glut main loop, it will display and it just terminates. So further you cannot use it. Okay. So next, individually, glut init is nothing but using the arguments and initialize the system. Display mode is, I told you, single buffering, colors, and in case you're using some logical or together, then you use the properties. Most of the time, we do not use this as of now with the syllabus. So glut init display mode will have two things. One is dealing with the color and the other one with the buffering. Another thing also you specify something called as depth, right? So glut underscore depth. This is for 3 dimensions, right? So when you speak about 3 dimensions, we actually add that. So glut window size will be in pixel. We saw that position where you want 0, 0 to 500, 0. This will also be with the pixels. Glut create window, you know about this. What's the name for that window? Glut display function is for the display callback. Glut main loop, enter infinite to the event loop. So we discussed something like display function over here. So we need to look into the display callback. So display callback is where the logic of the program actually resides. So once whatever the name which you give here, glut display function within the function, you gave that name, right? So that will be the function name. And so the control from the main program will come to this function. So once it comes to this function, now the first thing is previously the buffer will have some color bit, so that you have to clear. For example, see, this is the pen which I am using a red color, right? I need to clear that color. You can press into any of the colors, which it will actually rephrase, right? So clear the color refers to, it is by default, it is going for white color. It's going for white color. So next, you need to specify what is the color which you need to do, right? So initially we are clearing the color, meaning I don't have any colors. GL draw array, GL triangle 0, 3. So you are actually drawing the colors with some values of 0 and 3, and then you are going to flush, right? As of now, don't worry about this logic. So you should understand what is this display callback. So my display is the function where the logic goes here, and you start from here to here. So this is where the logic is. So you can use array buffer objects that contain the vertex array. It depends on your application. So when we speak about the vertex array, so this is the point, right? And this is the array. So what exactly you're telling here, the vertex will have multiple attributes, meaning it has some values in it. One can be position, one can be color, one can be the coordinates, and one can be the application data. So for as of now, I have 4 details, but for my program here, I'm not saving this application data. So position, color, and texture. Vertex array holds these data in application. So if you want to have these 4 data, you also have a header file which is called as vertices. So point 2 is the particular variable name. So this is the variable name. I have the vertices which is got from this header file, and it is having 3 values. So point 2 of 0, 0, and again, this is by default. You're telling that I have 3 values. So 1, 2, and 3. Each 3 of it are having 2 values. So point 2 is having the 0th value and the first value. So again, the 0th value and the first value. So 0th value and the first value. So this is in vertices of 0 array. This is in vertices of 1. This is in vertices of 2. So 0, 1, 2, that is our 3 values. So next we have to deal with the colors also, we take the same value. Colors as well as the positions. So positions can be, if it is a 2-dimension, you need to deal with X and Y value. Okay. If it is with respect to colors, then you may specify RGB value. RGB value. So get the name of the buffer. Okay. Dealing with the array with the array index. So buffer object. Fine. So we look into what do you mean by buffer object for our understanding. The memory manager in the buffer object will put the data into the best memory location based on user hints, user values, right? So instead of going through this, you understand that buffer is nothing but it's a temporary memory space. It's a temporary memory space, right? Which resides once the use of the buffer is done, it will be flushed, right? It will be deleted, right? Because that buffer will have new values to fill inside it. So next we have some creating of buffers. This probably will come back later. So initialization, there was a function called as initialization, something called as init method, right? So what it does, vertex array objects and buffer objects can be set up by the init. It also set the clear color and other OpenGL parameters, right? Also set up the shaders, important. As part of initialization, it is used for reading, compiling, as well as linking, right? So we'll look into the coordinate system, because we next comes some programs dealing with it. We'll understand that. So OpenGL camera. So OpenGL places a camera, right? So whatever we have, it's a screen. right? Camera is nothing but we are the camera actually. We are the viewers. So OpenGL places a camera at the origin in the object space pointing in the negative Z direction, right? So this is our, if I say this is my X and this is my Y, you are in the Z axis. This distance is Z axis. This distance is negative Z axis, right? So the right side is the X, the bottom or the top is the Y, and perpendicular to X and Y is your Z axis. Basically, you are viewing it. So the default viewing volume in the box centered at the origin with sides of length 2 will be from -1, -1 to 1, 1, 1. So here, as you can see, this particular box will be divided into 4 quadrants, right? So here, this is the X value is right, okay? The negative X value is left, okay? So Y, on the positive Y, it is top. On the negative Y, it is bottom. Okay. So the positive Z is near. Okay. So this box here is actually in the near. Okay. So this Z is actually in the near. So this back, whatever you see, right? So this box is far. This box is far. So by using these 6 values, you can represent any points on the vertices. So if I say this is right. Always go with X, Y, and Z. First X should come, then Y should come, and then Z should come. So what point is this? This is right, bottom, near. So what about this? This is left, bottom, near. So that's why you can see. So what about this point? This vertices is right, top, near. This is left, top, near. What about this?
Right, near, top.
Right, bottom, far. This is right, top, far. This is left, top, far. What about the last one here? Left, bottom, far. So these are the camera views which we can use. Okay. So the center from this particular line to this particular line, I'll just give you with the Z axis, right? E box madhya in the E box madhya. From this box middle to this box middle, your camera is actually placed. Okay. So moving from, that's what the sides of length to minus is nothing but negative with X value, negative with Y value, and negative with the Z value, right? So which will be on the other side. Okay. So 1, 1, 1 is nothing but positive with X value, positive with Y value, and with Z value. So here it comes. That is the volume of the box. So this is the box, whatever inside, this is called as volume of the box. So next comes the orthographic. Ortho means 90. Always remember that. Or orthographic with respect to the default orthographic is parallel view. All points in the view volume. What is that view volume which I told? The complete box inside the cuboid. Whatever you see, that is a volume. In the view volume are projected along the Z axis onto the plane 0, right? So this is our important thing. I want the Z. So middle point is over here. Z is also 0, Y is also 0, Z X is also 0, right? So I vary only the X and Y, keeping the Z as constant, keeping the Z as 0. Okay. So when you look into that, then we have all the points in the view volume are projected along the Z axis onto the plane. So you can see here. So this is a 2 dimension, right? Here my Z value is 0. Any changes with the X and Y value will be this. By default, the Z value will be 0, right? Yes. So next comes the viewport. Viewport is nothing but dealing with the x, y values. No, here we do not have the z value, right? X and y, meaning I'm clipping some value. See, the real world image is very big. I cannot insert the real world inside my viewing system, right? In the viewing system, I need to clip some of the sides, right? So here you can see what is that you are seeing, right? So what will be the size of it? So I'm viewing the x part as well as the y part, where within the x and y coordinate, I have the width, I have the height. So I have the width, I have the height. So this is my viewport. Inside this, from where I should start? That is the x and y. So from here you need to start. This is the x and y. From the x and y coordinate, how much width you have, how much height you have. That is something called as viewport. This particular viewport, which is over here, can start from here, can start from here, can start from here. Anywhere you want, it can start. But wherever it starts, it should have the width of W, it should have the height of H. So next we have the transformations and viewing. Not much important for the examination point. So this will be the last topic when it comes to the
Second
module 2.